to address the main points of the future digital ocean application worldwide, we have Pierre BAHUREL, who was opening the morning session, Director of General Mercator Ocean International for Ocean Forecasting Center, lead operator of the EU of the Copernicus Marine Service, and entrusted by UNESCO to help developing ocean forecasting. Then we have Sarah Kelly that just spoke, and Sarah Kelly is, as we know, an expert on the coupling, and she works at the ECMWF in Readings. You are responsible for the coupling of ocean sea ice, ocean surface wave models to the atmosphere, which is used in all forecast systems. Then we have just Marina, who was just speaking to us, had a nice presentation on the digital ocean, and you work in Toulouse with the Mercator Ocean International. You are an expert, as we saw, as we heard, on the forecasting and digital innovation. And last but not least, we have Mohan, Dr. Mohan Kumar, who comes all the way from Dhaka. He's Executive Director of the National Oceanographic and Maritime Institute in Dhaka and Joint Secretary of the SAMA, South Asian Meteorological Association. But you're also a specialist of communication with your expertise, so you make some real outreach. Okay, let's start with the keywords of our roundtable is applications and future. We'll discuss on the future and how they will shape ocean prediction. So, Pierre BAHUREL, if you want to open a little bit the session, we are diving into the digital ocean. Can you explain us what you mean by digital ocean systems and services? What are the main areas of application? And what are the main trends for the next 10 years, which is really our focus, and how this service is expected to evolve? Thank you.
Thank you. You hear me? Yes. Thank you, and hi again. So I think that at the time of the day, you understand what we mean by digital ocean. I mean, this is a super software where we are able to welcome the information from the satellites, from the in-situ observations, from the knowledge of research, so this is equations transformed into informatics and then super information. So we are now able today to deliver information that is three-dimensional, going in the past, to have the trends from the situation of today and explore the future. So this is what is our digital oceanography, and you have also now some examples of something that is fully operational, so we can deliver forecast, and also that is a tool for real research because we are using this. What I would like to explain, if we look to the features, is the evolution of it. We have started by feeding scientists with this. Let's talk about decades. The first decade, 2000, 2010, this time, or maybe 95 to 2005. The first users, they were the scientists. So we were using this digital oceanography to serve science. And our first users were very, very demanding because scientists, they cannot afford having something which is not accurate. So during 10 years, we have multiplied the effort to improve again and again this digital oceanography so that it can really enter at the right level, state of the art, to meet the research demand. So this is when we went from local models to global model, from global to local, high resolution, when we have added the new satellites, new information, new in-situ observation into the systems to do something which is what you have today, which is this super digital oceanography. And then during the last 2 decades, and this is when Copernicus has started, we are celebrating the 10 years of Copernicus this year, we went to something more operational with entrepreneurs, serving people that are They are not looking for something which is complicated. They want the data. They want to know the temperature. They want the forecast, and they want to be sure that if they are asking for something, it will be available. Plus a trust about the level of trust that you can have for the data. They are not asking for something that is super accurate, but they want to have the information which is timely, and they want to have some idea about the accuracy. Entrepreneurs, ship routing, aquaculture, coastal management, you name it. I mean, in every areas we have multiplied the number of applications, and we were the first to be surprised by the appetite of these operational users for this oceanography. So we have the scientists, then the entrepreneurs, and we are arriving now in a new kind of users that are the citizens and the policymakers. They want to know something about the ocean, and they want us to evolve our products to meet their demand. Policymakers, they want to be able to decide something with science to support their decisions. Citizens, they want to understand where they live. They want to understand what is happening in the ocean and how far this is important for them. So you're not any longer providing the data. You're not any longer providing scientific reports. You have to move to something else. So you have some digital tools there that are there to make them lively. You have these digital twins. So these digital twins, and I will end with this for the trends, is exactly the evolution of these service infrastructures where you are adding one thing. First, you have to be a bit more representative of the real ocean. So you are adding pollution. You are adding something that is bring by humanity, which is the stress on the ocean. You have also all the living resources must be added, so that you have a twin ocean that is representative of what you have outside. And then you're moving to the tools so that you can interact and ask all the questions you want, and you're the one asking the question to the ocean, and not me giving you the data to say help them. That's it.
Thank you, Pierre. We have to respect just the 5 minutes because we expect some questions from the audience. If not, Sarah, just a short one. How is the Sarah Kelly? How is the new way of coupling ocean wave and atmosphere models, along with using AI tools, to improve weather and climate prediction from a few days, as you said, to seasonal timescales?
Yeah, I think for us, I'm sat in between. I'm a demanding scientist and also someone who has demanding customers who want to make use of things. And I think the increase in fidelity of the ocean modeling affords us the ability to push what we can do with our predictions. And we start to see this with some of the examples. I didn't show one today, but medicanes, which are also an important feature for the region. We know that when we increase the resolution of these models and we improve the coupling between the ocean surface and the atmosphere, we can improve these forecasts. And the AI is a new player for us because we really want to see how we can really stretch our ability to provide useful predictions to society.
Okay, thank you very much. Let's go to Marina TONANI. You were just speaking, and you are the specialist of DTO, digital twin. How does international collaboration in ocean prediction, what that you call DITTO, accelerate progress in ocean modeling? And how these digital twins of the ocean enhance global and regional coastal monitoring, which is even more difficult, more challenging?
Yeah, so initiatives like the DITO program, so the Digital Twin Ocean program, can do is first together we bring together people. People that have expertise in the field, but they are also coming from different environments, from different continents, and so we are used to address problems in a slightly different way, or also to address different problems. But we are in the framework where we are able to share what is our expertise and also what we have developed. And this can help in developing ideas that have been tailored for one area and exporting this and adapt and fine-tune for another one. For example, Jan was showing as an application the natural-based solution, so how you can protect your coast from coastal erosion. With an example from the Wadden Sea. The Wadden Sea is along the coast of Germany and is a huge intertidal area. And this concept has been, for example, exported to the coast of Ghana, that is well far away and with a very different ocean dynamic, because there is dominated by a delta. And so the concept has been exported there and has been applied in that area, being able to develop a specific application where you can see how using mangroves to protect the coastal from the coastal erosion, how this can impact in a different scenario, using basically the same principle that was developed for the Wadden Sea, but for the Ghana coast. So this, I think, is, I hope, a clear example on how you can benefit of this collaboration for developing fast application and build up on ideas and expertise from other colleagues.
Yeah, great example. We have a journalist or a specialist from Ghana who is in the audience. Let's go to with Mohan Kumar Das. You come from a country which is very special in terms also of vulnerability and threats. I will just sum it up, but you know it quite well. You've been sometime, you told me, endangered in your own country. You've been focusing on, of course, rising sea levels, coastal erosion, hydrometeorological hazard, and your country is also facing these growing threats, not to mention monsoons, which are longer and longer, as you explained me, and the melting, I didn't know that, of the ice of the Himalayan ranges, which come also on your country. So my question is, given Bangladesh vulnerability to all these hazards, how can localized digital ocean applications better support prediction and response to cyclones, storm surges, and salinity intrusion for the agriculture fields? Thank you.
Thank you so much. I think you can hear me quite well. Okay.
Just close to the microphone because we have some competition.
Sure.
In the
so the concern,
in the big building.
What already been mentioned, Bangladesh is a very small country, but in terms of population, there is a huge population. That is the one thing, and it is a very deltaic country. Flat land is there. So such a small country, there is a many hazards, as you mentioned. Cyclone is there, and mesoscale convective systems. Those are called thunderstorms, tornado, hailstorm, and during the monsoon, heavy rainfall is there. So due to heavy rainfall, there are many places are flooding. So lots of issues are there. And tropical cyclone, every year, 2 different tropical cyclone seasons are there. In the pre-monsoon, especially March, April, and May, there is usually 1 or 2 tropical cyclone hit northern Bay of Bengal and very close to the coastal boundary of Bangladesh. And another season is October, November, December. So the issue is, when a cyclone, better prediction is needed. As you mentioned, digital twin of the ocean. You need ocean observation. But what is the reality? In the northern Bay of Bengal, there is no observatory at all. So no ocean observations. So if there is no ocean observations, in situ data is not there, how better prediction is possible? Only based on the satellite, right? No other options. So there is a gap.
Yeah.
There's a real gap. And second is when our organizations preparing the forecast, that is not up to the mark because of the gap of the real observations. That is the one important thing. And other presenter giving the forecast to the community, sometimes they are rely on that, sometimes they are not. If they are not rely on that, their life is vulnerable because maybe they are telling that it maybe hit some specific region. Maybe there is a 100-kilometer east or west shift is there. So the people who are not evacuated from that area, they are in a danger position. It happens in 2023. Within a season, October and November, 3 tropical cyclones hit over the regions. One is the Hamun, another is the Michang, and another is the Mocha, within a 2 months. So many fishermen, many coastal area people are died due to the storm surges, flooding, those things. So digital twin is the one a strong alternative to predict the ocean quite properly. Within this, I should demand real observation throughout the northern boundary of the Indian Ocean, specifically Bay of Bengal. Not only for Bangladesh, Myanmar is there. We can't ignore any countries, whether never separated the country in terms of the politics, right? Whether never maintain any politics. So there is no political boundary behind the weather events. So there is a possibility of hitting the tropical cyclone in the Bangladesh as well as the India as well as the Myanmar. So we have to have regional cooperation among the all countries. Second things regarding the digital twin of the ocean, as maybe in your presentation you mentioned, if you insert our local data like a strong Doppler weather radar, coastal radar, if coastal radar data can be incorporated into the numerical model, there is 2 parts. One is the artificial intelligence, another is the physical part of the model. So physical part is fully numerical model driven, and forecast improvement is the AI driven. So there is 2 things. So if we really used our own data into the system, the forecast will be improved, and our weather person can give the proper dissemination to the community, and community will be helped. Another small example regarding the small island country, Maldives. There is a very small country, but most of the Europe ECMWF data is 0.125 degree resolutions. So Maldives is covered within the maybe 1 or 2 data, really. So Copernicus is a bit alternative, because Copernicus data comparatively better, resolution is quite better. But still, a small country needs far better data. Then that will be helpful to the community.
Okay. Thank you, Mohan. Prepare some questions, because I'm sure there are a lot of questions about Bangladesh and other places in the world. Pierre BAHUREL, so we understand from you all that this new digital information system will drive a significant shift in how we generate, share, and access information about the ocean. They are called upon to play a key role in supporting the ocean governance. What are the main challenges in this matter, and the community's responses to this challenge?
Well, we know where we are. We are just a few days before the start of the UN Ocean Conference, where political leaders will gather and talk about the ocean and hopefully take decisions on this. And we want science to be really the base of their decisions. We understood from Mohan the fact that we will really need to interconnect all the systems where they are, that we will need to accelerate the circulation of information, increase the data. We heard from Salah that artificial intelligence is a real shift and will accelerate. What I'm asking today, the question is, how can we ourselves be sure that we will provide something that is true, that you can trust, that you can really play with it. I mean, the level of confidence must be super high. We need to with this super model, super software, you can also say something that is completely stupid and false. So I need, my point is that we need to have the organization at the operational organization to maximize the level of confidence that you have. So everything must be based on science, verify, and when we release the data, tools or something, we give you the possibility. You must have also the possibility or to check and to have the proof by the scientists that this is very true. And we are very well organized as scientists in this matter. When we work together and when we go outside with you, this is what we are now providing with indicators, with quality check, with all the things. So this is done, but we want to maximize this part. And the last point is the governance. The fact that we want to protect this area, to have a space of trust, and to have the governance for the ocean where we can really play together and be sure that the science is protected, that the science is verified and can be shared with everything. We have many examples. I have one close to me, which is the transformation of Mercator into intergovernmental organization, where we invite the states in the discussion, and we really set a governance when all this digital oceanography will be proposed for the governmental decisions based on the science. So verified by science and protected by a transparent governance is, I believe, something which is fundamental if we want to really play all together this game.
Excuse me, I have a question, a personal question as a journalist. Jean Jouzel was saying this morning that now there's a problem about science, which is quite challenging. Do you think in what you are saying, there will be a political dimension coming in, or just the competence of scientists and this intergovernmental structure?
Okay, so I know where you're going. What I say is that, look, the four of us,
yep,
we are ready to work together, and we are ready to share the information, and we want to share it, and we know that we will be better if we work together. And this is what we do every day. So my answer to you is, yes, there is an issue, but we can be offensive by proposing something that is exactly what we want to happen, which is collaboration between organizations, ECMWF and Mercator, your organization and ours, and propose something. And today in Europe, this is where I live, there is something that is, I believe, of very good quality for this. And this is completely open to the world. And what was mentioned, I stop with this, what was mentioned by Marina, this DITO program, yep, is exactly the sign that it has to be done at the international level. So I'm not commenting what is going bad. I said what is good. And what is good is that we have with the UN Decade, the IOC UNESCO UN Decade, a program where we have still 5 years to go. We can really build this organization at the international level with a fruitful collaboration. And we, scientists, we are moved by this, and I think that with this UN Ocean Conference, we could be at a tipping point for that.
Thank you very much. Marina TONANI, you told us very clearly that digital ocean technologies such as original ocean digital twins offer innovative ways. What are the most promising innovations in this field, and what challenge and limitation must we overcome to ensure that these tools are truly enhancing integrated ocean knowledge and decision making?
Yeah, so I think that the complexity of the marine environment is really huge, and as scientists we are used to tackle part of it because we have our own expertise. And so if we look at the different applications that have been shown today, they are addressing a specific issue, a specific problem, but everything is interlinked. So you need to have information not only on the physical component, but also on the biology. So if, for example, if there is a problem of coastal erosion, this will have an impact also on the life, the ecosystem that is there. So everything is linked. And the first step of this digital innovation is that we are able to develop several applications, but then I think the challenge is how we can interconnect all of them so that we have a comprehensive understanding of what is the impact of an action or of an issue, yep, on the entire cycle of the ocean environment. That I think is really difficult, but I think is really a game changer because will allow us to be able to share not only among communities that are working on a similar topic, yeah, but also with communities that are really diverse. I'm a physical oceanographer as my background. If I have to discuss what could be the standard for sharing data with someone who is biology, yep, I'm sure that I will struggle a bit. But I hope that in this framework of collaboration, that is not just international, but is also cross-discipline, of course, in this case, linked to the marine environment, but also not only, because then the ocean is connected to the land and to the atmosphere, so we can expand. But I hope that the technology will help us to lower this barrier and to really be able to have a full overview of the problem.
Thank you. Sarah Kelly, what are the future directions that you are looking for in terms of development for coupled forecasting?
So I think there is the interplay of complexity. So we're interested in capturing the elements of the Earth system that are important for the forecasting. We talked about, you talked about the glacial issue, and one of the things that we look for in the future is coupling the runoff that we have from the land surface into the ocean directly, so that we can really model the freshwater exchanges correctly. Yep. The other thing, as we talked about before, is the resolution, both in the vertical resolution and in the horizontal resolution of the models we use, to improve that fidelity and continue to assess how the systems perform in different environments, so that we can have useful tools and credible tools for supporting society with early hazard warnings as well. You mentioned as well, Mohan, that you have to have a credible forecast that people are willing to act on. And so demonstrating that our systems are credible, I think, is a really important thing to do. And so we rely then on the observations to convince us that what we're doing is sound and verifiable. And then in terms of, so there's the complexity, both with the atmosphere and the ocean, to provide increased skill in our forecasts, and then looking at longer lead times to give earlier warnings to society as well.
Okay, thank you. Let's go to the complex situation of Bangladesh, and Mohan Kumar Das. How can digital oceans be adapted to provide timely and localized and accessible data for coastal communities in a journalist-friendly format? And given the financial constraint, how that's possible to ensure sustained access to these tools?
Thank you. I think these are very excellent questions. I think, really. Like in our region, not only one country, many countries are there. So we are planning to implement digital twin of the ocean. I think there should be something like South Asian digital twin of ocean. That is not for one country. Like as you shown opera, right? One opera and another one. I'm not so much know about that, but something like this. So we have to introduce something like this. So that will be much more effective, one. Second is the capacity building. Like I can share one small example. Tropical cyclone is fully ocean-based phenomena. When journalists explain this, like one mesoscale or convective system or tornado happen in the land, they are writing or they are telling that cyclone happen in this district. That exactly not. One is the cyclone, it is ocean phenomena. The thunderstorm or some tornadic vortex, that is land-based phenomena. So really need some capacity building activity for the journalist as well as the early career professionals, mid-career or whatever. So capacity enhancement is very much needed. It should be like from my institute, National Oceanographic and Maritime Institute, we are offering simple capacity building, like how to use the net CDF data, as you mentioned. There is various kinds of data, gridded binary 1, gridded binary 2 for the numerical model. And net CDF data is new version, right? So they need to know the Python or some other code. So if people know those things, so that, even biological scientists, if they know how to read the data, they can easily use it. So, like this. So a small training capacity can enhance. Funding is an issue, like why we are doing science. Why? For the community. Whatever the science behind the black box, and then it is for the community. So we have to have some mechanism how this thing can be converted for the community in their language. Like And another organization I mentioned, South Asian Meteorological Organization, that is for the 9 countries organization. Start from Afghanistan, Pakistan, India, Bhutan, Nepal, Bangladesh, Sri Lanka, Maldives, Myanmar included. So if something happened in some area like dust storm, hailstorm, or tropical cyclone or something, we request the Myanmar people, please make this outlook as your language, so your people can understand this. Like for Maldives, please make it in your own language. Sri Lankan people, please make it. And there is some other issues. Like in Bangladesh, there is a Bengali language, is okay. But region to region, there is a language variation, right? So a standard Bengali language cannot be understood by all the local community. So you have to, some kinds of, through the radio or others, you have to convert it their own localized language. That's also important. So who will do it? Other men, right? Other presenters. So this kinds of communication is needed. So funding, not so much funding, like $1 million investment is not required. Very small funding can give very big results for the community, for the regional enhancement.
Don't speak too quickly for the translators. So,
oh, sorry.
Any questions in the... Yes, please.
Hello, this is for Sarah. Sarah, what about the accuracy of the AI products for tropical cyclones?
So we're initially seeing with the latest AI products that we capture the tracks far better, so the evolution of the passage of the storm. But the intensity and the exact location of the precipitation, I think, is still better captured in the IFS, so in the physical models. And at the moment, the AI models are at fairly low resolution. And so something that we're moving to going forwards is then looking at the higher resolution systems to improve that. But yes, but better for tracks, not so good for the intensity at the moment. Yeah.
Any questions? Yes. Excuse me. She asked earlier.
Thank you. So right at the beginning, the introduction was we would love meteorologists to use our products in their weather forecasts. How do you see that happening? That's an open question to everybody.
First, I guess we need to use this forum to organize a dialogue to understand what you need, and then share with you all the data, the forecast, the visuals, the tools that we have. We are playing with this ourselves. We are playing as we mimic you. I mean, we have our forecast and we try to use that. So I think you could do better, but of course, if you propose a forecast of the temperature of the sea for the next 10 days or the salinity at 5,000 meter deeps, maybe your targeted audience will consider that this is for information, but they don't feel like. What we have today is, for instance, if you go to this digital twin demonstration there, you have examples, real examples of the impact of this ocean forecast. If you start showcasing the forecast of the pollution that is shifted by the currents that will use the coast of X or Y, or if you go backwards to understand the origin of the pollution, that you can explain that thanks to the forecast today, if you found something here, it means that it was generated at this moment, then you start building stories that is probably more impactful for your things. So I believe that the forecast of the currents itself is one thing. This is our job, and we do it well, and we are happy with this. But we are now offering tools. For instance, this is a digital ocean, and now we have digital turtles born in Costa Rica, on the beach of Costa Rica, crossing the Atlantic to reach the Morocco. So this kind of stories can maybe open a door in the to your targeted audience. So this is what I hope with all the tools that you could have.
Hi. I think this question is for Marina. I'm really interested in the digital twins question, and especially thinking about the application for climate change attribution. And I'm wondering whether you have any digital twins that are being run in a previous climate, for example, a no global warming climate, to look at how a phenomenon plays out now because of 1.3 degrees of warming.
So thank you very much for your question. So in the demonstration behind you, we do not have this yet. It's a very interesting point, and for sure it will be included soon, because we are fast developing these applications. So we have now targeted a few examples, and what we are showcasing here is really a small sub-sample of what can be, let's say, nicely displayed in a way that we can easily explain without being expert. But of course, this is one of the use of the digital twin that can allow us to play with the time backward and forward, so that we can understand the what-if scenario also playing in the past, so that we can better understand what is the situation now and what has been the history, and understanding from that for looking at our future. So the tool is there, everything is there. It's just a matter to build the application and to target a good case, so that we can have this and we can showcase this and make this available to whoever needs it.
A lot of work ahead and requests from the people. We had a follow-up question here.
Yeah, sorry, my question. Oh, sorry. The question was just: are everybody's products free to use?
Yes. This is open to all, and this is free to all, because this is funded by the European Commission.
Most of our broadcast systems can use KML products. Do you have that option in order for us to use them on air? Or would you consider it for the future?
I think so. Sometime she's asking for KML product, right? So yeah, I have seen some site like what is called a Joint Typhoon Warning Center. They provide the KML product of their product. Just I want to include one or two things as per her question and his question. So we are receiving the information through the digital twin. So maybe end of the year or end of the season, verification is required, right? Verification. So how accurate is it? And I think one of my Poland friend is there. Maybe end of the season or end of the year, he can present last 1 year, this much of weather event, we warn the people, but out of the 10, 7 is occurred, 3 not occurred. The people can rely 70% accuracy, 90% accuracy is there. Thank you.
Yes, I think that the accuracy of the information is really a key aspect, and maybe sometimes in the ocean could be a little bit tricky to do this verification, because if I'm going to say tonight at 7 is going to rain, all of you can verify what I'm saying. If I'm saying off the coast of Nice, there will be a current moving southward with 1.5 knots, I think that much less people will be there able to measure if I'm right or wrong. But having said that, we have several observations and several tools and ways to understand how accurate is the information that we provide. And I think a good example is from the Copernicus Marine Service, where we have implemented an operational system where we are verifying our forecast in real time, and also for the past month we do verify continuously the accuracy of our forecast against to the observation, and this provides you a very accurate information along minimum the 2 years in the past for each forecasting component. And I think that this is a good practice that we are going to implement also in the digital twin, where we need to be really to do really a job where we can be able to simplify this process and to make this information easily accessible and comprehensible to everyone. Because more you open and more you populate with information, and more you need to be sure that you have a control on the quality and the accuracy.
So you need more and more, if I may have a joke, Marina, you need more and more cooperation with the press, with the journalists, at least the specialized journalists on weather. Excuse me.
Not at all. So really, I have two questions, if I could. We know that satellites are being turned off in the United States and that NOAA is being defunded. Will you be able to make up that kind of huge deficit that's being created in terms of weather data in the US? Second question really is a general one having to do with the absorption of heat in the ocean. Your views as to whether how close we are to a tipping point that people refer to. There are several tipping points that the Potsdam Institute talks about with regard to climate change. And I just wonder how close we are to a maximum point where the ocean will not be able to absorb more heat. And sorry for the layman's understanding of that point.
I take the first one, you take the second. For the first one, yes, of course, we are worried by the situation, and our friends at the United States, they are doing very well in building the systems and satellites and in situ observations. So since decades, we are been working with them, and we will continue as much as possible. But yes, there is a high risk, and we know that there are some cuts that will impact us. What I have in mind is that, so typically when we think about the Argo floats that are this kind of submarine drones to observe things, 57% of them are from the United States. So if they stop this, there is a huge impact. The good news in this, at least from where I sit, is that Europe is quite strong in so the statement is clear. The satellite segment we are lucky to have satellite organizations that are strong in Europe and elsewhere in the world that are very well organized to this. So this is an important part. And for what regards the ocean observations, only focusing on Europe, not to say that they are the only ones, but this is where I'm looking precisely. The President of the European Commission will announce that they have a European Ocean Pact, saying that the ocean is fundamental and important, and they want to reinvest in observations, which I hope will happen. So we can be a bit offensive in this and rebalance a bit the dependency of different parts of the world vis-à-vis the United States. But I really hope that we will catch up with the situation, with a normal situation that we will go to it. And also, and this is my last word, you understand now that our systems are critically dependent on observations, but also that we are multiplying the sources. We have really multiple sources of information. So you can have one data that is going down, you have the other. So when you play with different satellite missions, with different sources of information, different countries, different things, you're a bit more resilient. But okay, not to say that this is not a worry, but we are organized to deliver. So the forecast will continue. The forecast will continue, and if there is an impact on the accuracy, it will be precisely said. Maybe for the second one, you want to...
I can share a small example. Maybe many of you know global precipitation measurement data. This is called GPM, GPM data. So previously, it was tropical rainfall measuring mission data. So the mission was stopped after 10, 15 years. So that is a sudden problem. But of course, we are optimistic. If some problem happen in some parts, another window will be open. So that is actually, we scientists hoping best for the community. Thank you.
Thank you. Other questions? Yep. From South Africa, if I'm right.
Thanks very much. I just want to know your general advice having all this ocean information and data, also looking at AI forecast, what is your general advice to coastal communities? Like, as you look at it, is it still safe to stay there? Or what should happen? I'm not saying take a decision, but just a general advice to coastal areas.
That is very important questions. In such a sense, you see, the country which are very populated, like Bangladesh, one example. So most people living in the coastal regions because food is there, facilities is there. So we cannot tell them, or we cannot remove them from the close to the coast. The issue is their housing is not standard to maintain the strong wind of the cyclone and others. So the advice should be something like this. It should be comes from the policymaker or government to make a better management for the coastal community, one. Second is the rely on the weather forecast, whatever it is. If it is wrong, please rely. Otherwise, your life will be vulnerable. If it is 60% accurate, please rely on that. Please evacuate for some specific hazards or others. I think that's the maybe one suggestion from the weather community. Maybe you can include more.
I do believe that more we increase the complexity, the accuracy, and also the technology that is behind our capacity to forecast, this means also that you will get the information faster and in a timely manner, and will be also information targeted for your own area. And I think that this will increase the awareness of what is the risk, and will also diversify the risk, because it's not the same everywhere, but will allow you to understand where is safe and where is less safe, and when is safe and when is not. And I think that as human beings, we love living close to the coast. There are several benefits in being there. We have always almost be there. And I think that we need to find a way to be able to stay there as much as possible, of course, and with all the constraints that we have to face with this environment that is changing.
We have 10 more minutes, so we have, I have a lot of questions. Perhaps you have some. Yes, again, please.
Je veux aller en français. Merci. Je veux aller en français. C'est possible? Bon, je serai plus à l'aise comme ça à parler pour pouvoir trouver tous mes mots, quoi. Oui. Est-ce qu'il n'y a pas de traduction pour eux? Oui, il y a la traduction, mais ils n'ont pas le casque. Il n'y a pas de souci. En fait, ce n'est pas une question. Bon, je les laisse. D'accord. OK. C'est plutôt pour essayer de répondre à la question du monsieur tout à l'heure. Et moi, j'ai un apport à cette question. Bon, en réalité, sa question, c'est de savoir qu'est-ce qu'il faut faire par rapport à la population qui se met au niveau donc, de la côte et quel est disons, le conseil qu'il faut donner. En réalité, personnellement, moi, je suis météorologiste. D'accord. Voilà. Donc, du coup, moi, je suis d'accord pour le fait qu'il faudrait que nos gouvernants puissent essayer avec les scientifiques de chaque pays, essayer de définir une limite au niveau de nos côtes, au niveau de nos berges, où on ne peut pas tolérer la population à s'installer. Parce que nous avons des événements au fait, au pays qui ont montré qu'il y a des gens qui se mettent par exemple à quelques 10 mètres seulement de la mer. Et du coup, la mer vient, les vagues viennent et les envahissent. Et des gens, nous avons perdu beaucoup de personnes. Voilà.
This is a challenge about, of course, living on the coast. It's challenges everywhere, as you know. all around the world, almost on the coastlines. But the experts have for sure something to say about, to comment about this. Yes, about the challenge of how close can we live and what the government should do according to the country and the threats.
No, I just want to mention that if you have a chance to go to the digital twin ocean demonstrations, there is one application dedicated on this when you can decide a part of, I think this is only for Europe, and you can play with this to understand the impact of different climate scenery on the coastal for the buildings and for the persons. So it's a way to communicate this information and say that there are different situations in different areas.
So there is much more work to do in worldwide, no? For sure. And I have a question about that to Marina, Marina TONANI. How the international collaboration can facilitate the development of digital twins and the sharing of ocean expertise worldwide?
So, as I explained, having this network that encompasses community, so people that are coming from different institutes and different continents and countries that are working together for developing common tools and best practices, will allow to develop a common environment where we can quickly develop a new component and interconnect them in a very efficient way, and this will increase our capacity of monitoring and understanding the ocean and the sea environment. And this could be, for example, so what was just mentioned by Pierre about the application that we are showcasing in the digital booth there, about the risk that had been assessed in terms of impact on buildings and on people and infrastructure along the European coast. Is something that other countries can leverage on it and see how it could be adapted and extended to other areas, and maybe we can also improve the concept, because then there is a sort of feedback information that can help to further develop and go to the next step for being even more accurate and precise.
Thank you. Any questions in the audience? Let's take advantage, Mohan Kumar Das. What role do weather journalists play in public building trust and understanding ocean forecasts? And how can digital platforms improve this communication? And could AI, although you touch it, this issue, could help in certifying the reliability of ocean information? Do you think it's a very helpful tool and positive vector?
Yes, I should say yes, of course. Technology is very much needed because, as I mentioned previously, we don't have that much of information from our different locations. So we have to depends on some technology. If digital twin is there, if some other strong modeling system is there, we should rely on that. So weather presenters usually depends on different sources, not only one sources. As he mentioned, as a government representative, so we cannot rely on only for government representative, because public and private both what is called partnership is required. Otherwise, sometimes it is not that much effective to the community. So whether presenters are giving or delivering something, there is actually two channels. One is straightforward from the government channels, another is from the private channels. So if there is some coordination or harmony or some integration, that will be much more effective. Sometimes it is this. Sometimes these kinds of lacks are there. Usually, developing country, there is some system. Mostly, the system depends on the government procedure. But we found some public system also quite tremendously improving. But they cannot reach to the whole community. Sometimes they reach only some specific targeted community. So their straightforward needs some linkage. Then that will be, community will be much more benefited. It is my understanding as per some other countries' observation also. I can share one experience of tropical cyclone Nargis.
Yeah.
It happened in Myanmar. So can you still think in this decade, more than 1 lakh, 2 lakh people died only because of the cyclone? So it is a lack of dissemination of information. So it is the failure of total government system as well as the private system.
Yeah.
And the information not reach specific to that community. It is just 5-7 years back. So this misunderstanding is there. So still coordination is required. Because some political problem is there, some other issues are there, the dissemination channel network is not working, right? If some hazards happen, there is no mobile network. So how information will reach to the people? There should be some sustainable way.
Okay.
Yeah. So community people involvement is important.
Perhaps a final question. We have 4 minutes, which is pretty good. Pierre BAHUREL, I come back a little bit to this issue, although you addressed it somehow, but I think it's quite important about the governance. How this governance you were mentioning could work in an era of hard science can be being erased by fake news. How can we guarantee the reliability and certification of a global system?
So I think that the ocean must have the same level of recognition than others thematics. So intergovernmental organizations to provide standards, to organize the things. Then a good community, then good products. Then we must be organized as a community to provide not only the data, the tools, or everything to you, but also the trust. But the battle is to have the people understanding that this is important. One short story about one guy, okay? Short story. The name of the guy is Joni Johannessen, okay? A young guy working, so at the start of the career, he went to the European Space Agency, expert in satellite. Then he went back to Norway, he's Norwegian. He created the ocean forecasting centers, one of the best ones in the north. Then he went to create centers in South Africa, partnership, Russia, India, so to be international. He went with me to help me developing the European system, Copernicus. And then he joined Mercator. On Monday, Norway will join the Intergovernmental Organization. This guy, he went to Tromsø. He went on a ship, a tall ship, an old ship, Norwegian ship, sailing Tromsø. 30 students from Tromsø, like 5 weeks. Tromsø, Reykjavik, Atlantic, storms. And he arrived in Nice 2 days ago. The students, they completely changed their life. They were, during 5 weeks, they were fed with satellite data, speech about the ocean, the et cetera, and this young generation, they will do what I hope, which is to be connecting to the ocean. And this guy, Joni Johannessen, is there. So I give him the floor to explain how it changed the life.
Amazing, amazing. Go ahead, you have just 1 minute to finish on time, but...
Well, that was a surprise to be... what I can say is that having the chance to bring 50 students on board a tall ship, to sleep in hammocks, to be sharing toilets and bathrooms, not having any privacy whatsoever, creates a new level of respect, recognition of each other, and sharing the enthusiasm and inspiration and curiosity for this beautiful blue ocean we have. And if we are not careful enough, what we are on the way of doing with it is, it's very important therefore to bring this information across to every layer of the society. And the digital ocean and the digital twin is an extremely powerful way of doing that.
Great, that's a great experience.